So in this last example in lesson 5.5, I want to relate these radical equations to a real-world situation. So I think we've looked at this formula before where you can estimate the speed that a car is driving by measuring the length of if it comes to a complete stop, by measuring the length of the skid marks and the what we call the coefficient of friction. So that factors in, okay, are we driving on pavement? Are we driving on dirt roads? Are we driving on rainy roads? Are we driving on snow? That's what the coefficient of friction is factoring in. So currently this formula, S equals the square root of 30 df, is set equal to S, the speed of the car. Well, we might rather want to be able to identify approximately how much distance we should leave between our car and the car in front of us in order to be able to stop in time not to hit the car in front of us. So we might instead want to determine D, the length of the skid. Because if the length of the skid represents the distance it takes before the car stops, then that will give us an idea of how much space we need to leave between our car and the one in front of us. So we're going to basically take this formula, currently in the form of S equals, given in terms of D and F, and we want to solve for D. We want to be able to determine distance necessary given speed and coefficient of friction to leave between our car and the one in front of us to make sure we don't hit that car when we slam on the brakes. So to solve for D, we first notice that it lies underneath the radical. So, and the radical is alone, which is important. We talked about that with our previous examples. So to eliminate the radical, we're going to just square both sides, like we did in our previous examples. And now we'll have S squared is equal to everything under the radical, we call that the radicand, 30 df, without the radical. And now we're solving for D, and we notice that it's being multiplied by F and by 30, so we can divide by 30F on both sides of our equal sign to get the D alone. These 30s will cancel, and the F's will cancel. And we will have D equals all by itself. So now we know that the distance or length of the skid, or distance that is necessary to leave between our car and the car in front of us in order to be able to stop in time, is equal to the speed squared divided by 30 times the coefficient of friction. So it's the same formula, but now it's solved for D in terms of F. So now we can use it to answer this last question. So suppose that for a particular road surface, the coefficient of friction is 0.35. So we're going to put that in for F. And we want to determine how far will a car skid when the brakes are applied at 60 miles per hour. So we're going to plug that in for S. So we'll have 60 squared over 30 times 0.35. Now, what's key here is when you go to plug this in your calculator, it is crucial, because there's an operation in the denominator, it is crucial that you enclose that denominator in parentheses. Okay? So I'm going to type 60 squared divided by, open paren, 30 times 0.35, closed paren. And when you do that on your calculator, do it yourself to verify, you should find that your distance or length of the skid mark would be 343 feet. So if you want to avoid hitting the car in front of you, you need to leave at least that much distance between you and that car.